Welcome back, students. This is the Q&A session 4 from the playlist of electromagnetic induction, and today I have taken one question which is based on the magnetic flux in the Faraday's law of induction. So here the question is: a circular coil of radius 10 centimeter and 500 turns and having a resistance of 2 ohm is placed with its plane perpendicular to the horizontal component of the Earth's magnetic field. So here what I have done is I have simply drawn one diagram in which I have depicted the horizontal component of the Earth's magnetic field by these arrows, and I have denoted this magnetic field as B, and this is one circular coil which is placed in this horizontal component of the Earth's magnetic field in such a way that its plane is perpendicular to this horizontal component of the Earth's magnetic field. So if its plane is perpendicular to this magnetic field, then the normal to the coil will be parallel to this magnetic field. So this is the normal to the coil. So the angle between the direction of the magnetic field and the normal to this coil is 0. That is theta is the angle between the direction of the magnetic field and the normal to this coil. So this will be equal to 0 degrees. Now this coil is rotated about its vertical diameter. So this is the vertical diameter. Let us say this is the center of the coil. So this is the vertical diameter which I am denoting here with the help of this dotted line. So it is rotated about its vertical diameter through 180 degree in 0.25 seconds. So we have to find the magnitude of the EMF and the current which is induced in this coil. So in order to find the magnitude of the induced EMF, we will be using here two formulas. First one is that the formula for the induced EMF is given by N delta phi upon dt, delta phi upon delta t, where delta phi is the change in the magnetic flux and delta t is the time interval, and N is the number of turns in the coil. So this is basically the magnitude of the induced EMF. Now, so here the value of N is equal to 500 because this circular coil has got 500 turns. Now here we have to find the value of delta phi. Now what is delta phi? Delta phi is basically the change in the magnetic flux. It is the change in the magnetic flux due to the rotation of this coil by 180 degrees. So we know that the magnetic flux which is passing through this coil surface is given by B A cos theta, where theta is the angle between the direction of the magnetic field and the normal to the to this coil. So theta here is equal to 0. So simply this formula in this case will be equal to B dot A. A is what? A is the surface area of this coil. So the flux, the initial flux will be equal to B. The value of B is given to us as 3 into 10 to the power minus 5 Tesla. So I will be just writing this value as 3 into 10 to power minus 5, and the area of cross section will be equal to pi r square. Here r is given in centimeters, so I will be converting into meter. So this will be equal to into 1 by 10 whole square. So this is the area of this circular coil, and so the initial magnetic flux which is linked with this coil is equal to 3 into 10 to the power minus 5 into pi into 10 to the power. This is 1 by 10. So this if I just take this 10 in the numerator, so I will be getting is as 10 to the power minus 2. So the value of this is equal to 3 pi into 10 to the power minus 7 Tesla meter square. So this is the initial flux which is linked with this coil, and the final flux. Final means the flux which is linked with this coil when it is rotated about its vertical diameter through 180 degree. So this will be equal to, this will be equal to BA cos theta. So this will be equal to 3 into 10 to the power minus 5 into pi r square. So r, this will be equal to 10 to the power minus 2 into, now cos, here the theta will be equal to 180 degree, because this coil has rotated through 180 degrees, so the theta here will be equal to 180 degrees. So here the value of this flux which is linked with the coil after it is rotated through 180 degree, so this will be equal to 3 into, this will be equal to, now cos 180 will be, the value of cos 180 is minus 1, so this will be equal to minus 3 pi into 10 to the power minus 7 Tesla meter square. So the change in the magnetic flux due to this rotation will be equal to, that is delta phi will be equal to 3 pi into 10 to the power minus 7 minus, in bracket, minus 3 pi into 10 to the power minus 7 Tesla meter square. Okay, so this is the change in the magnetic flux due to the rotation of the coil by 180 degree, and this will be equal to 6 pi into 10 to the power minus 7 Tesla meter square. Now the induced EMF is equal to N delta phi upon delta T. So here the number of turns is 500 into, now delta phi is equal to 6 pi into 10 to the power minus 7 divided by, now delta T here is 0.25 seconds. So the induced EMF, the value of the induced EMF will be equal to this, I will just simplify this value, that is equal to 6 pi into 10 to the power minus 7 into 10 to the power 2, because I have removed this decimal from here, so this 100 will go into the numerator and divide by 25, so this is equal to 20, and this is equal to 6 into 2, that is equal to 120 pi into 10 to the power minus 5. So if I just calculate this value with the help of a calculator, so I will be getting this one as 120 into 3.14, because the value of pi I have taken is as 3.14, so this is equal to 376.8, 376.8 divided by 10 to the power 5. So the value of the induced EMF is equal to 3. So the value of the induced EMF, this will be equal to 3. Or we can write it as 376.8 into 10 to the power minus 5 or we can also write it as 3.768 into 10 to the power minus 3 volts, or this can be also written as this, that is, if I just round it off, so this value will become equal to 3.8 into 10 to the power minus 3 volts. So the value of the induced EMF is equal to 3.8. This is the approximate value, 3.8 into 10 to the power minus 3 volts. And now we have to find the magnitude of the induced current. So the magnitude of the induced current will be equal to, now the value of the induced current, this will be equal to induced EMF divided by the resistance of the coil. So this is equal to 3.8 into 10 to the power minus 3 divided by the resistance of the coil is how much? It is 2 ohms. So the value of the induced EMF will be equal to 1.9 into 10 to the power minus 3 ampere. So the value of the induced current is equal to 1.9 into 10 to the power minus 3 ampere, and the value of the induced EMF was equal to 3.8 into 10 to the power minus 3 volts. So thank you very much for joining this session. I hope you have understood the solution of this question. So the most important thing which you have to remember in this question is that first of all you have to find the change in the magnetic flux due to the rotation of the coil, and thereafter you have to simply use the formula, that is the induced EMF is equal to N delta phi upon dt. After calculating the induced EMF, you can calculate the value of the induced current by using this formula, that is I will be equal to, induced current will be equal to induced EMF divided by the resistance of the coil. So thank you very much again, and I hope you have understood the solution of this question. And in the next question I will be coming up with the Lenz's law. So till then, have a nice day. Bye.